Okay, so when you go through and demonstrate the area formula for a parallelogram, a couple things that you'll want to do. First thing is you're going to calculate a distance. So if we measure the distance of our base, so we can just measure that length. And then we have to find the corresponding height. Well, the corresponding height to this is going to be a perpendicular segment from the vertex to that opposite base. So if you select the vertex and the opposite base, and then construct a perpendicular through that, and that allows you to find your height. Now, what happens in this is this height doesn't necessarily pass through the actual base. So in order to find the intersection and the real height of that, you need to extend your base. So you can extend the base easily by just selecting 2 points and then either constructing a line or a ray to show that. And then if you want to find where that intersection occurs, if you just highlight the two segments themselves and choose Construct Intersection, it'll find where that point meets. And so then the final step is if you just select, again, that point's already selected, select the point at the top base, at the top of that parallelogram, and then you could either hit Control L to create a segment there, or you can just measure the distance of it. And the distance is fine. So we get this height of 3.18 that corresponds to this base of 3.23. So when you actually calculate, you can go to Number, Calculate. You want to calculate base times height. And in doing that, you get your area of 10.25. And now it asks you to demonstrate this using both pair bases and heights. And so remember, the other base that we could have used was AD. So if we measure that base, so there's our length, and we find the corresponding height for that. And so to find the corresponding height from AD, if we take a point on our base and we construct a perpendicular to that opposite base, so select the base, construct a perpendicular, and then again you can find the intersection of this. This one now it's easier to see where the intersection is, so if you want you can use the intersection command or just identify your point. Measure the distance between these 2 points. Again, it'll be a distance instead of a length on this. And now we can confirm that this area formula works by going back to our calculator and taking this new base times its corresponding height and finding out that it is equal. And if you move these around, what you see is that's always going to hold true. And the area that you get using one base and height is the same as the area you get using the other base and height. And now let's say you wanted to even further confirm that this is the correct area. If you highlight each of the vertices of this figure, so not the intersection but the vertex or the vertices of your parallelogram, and then you hit either Control P or you go up to Construct and choose this interior. It'll say whatever the form is. It's a quadrilateral interior, and so it'll shade that whole interior for you. And once you have that shaded region selected, and again if you don't have it selected, you just click on it and you can go to Measure and choose Area, and it'll find the area of that whole figure for you. So once again you can confirm that this is what the area should be, and our calculations for base and height are equal to that. So it again verifies that. All right, so it's going to ask you to do that for each of the remaining pieces. And the one other thing that is kind of different from that would be this question number 5, which is demonstrate that the area stays the same when a parallelogram is sheared. Okay, so if we think about what shearing is once again, so if you click a point and we just want to extend these 2 sides. So if you just highlight the 2 sides and construct a line, do the same thing, highlight the 2 sides and construct a line. And you can kind of get the idea actually in this one. Oops. You can leave the base the same, you don't have to change that. If you just highlight the 2 vertices on the top, construct a line to extend it. Okay, what you want to do is you want to compare the area of this figure right here. So again, easiest thing to do is just to highlight the vertices, hit Control P to fill it, and then measure that area. And so here is the area of that purple parallelogram. And remember, what shearing does is it allows you, or you just slide the points along. So we want to create a new parallelogram that has this same base, CG, but it's angled at a different point. So you can choose anywhere to draw a line from point C. Okay, and then all you have to do is to create a parallelogram off of this line right here is, and again, this is probably something new, but if you pick this point on the parallel line, and then you choose the distance from the base, okay, that distance CG, and what you can then do is you can construct a circle by center and radius. So you selected a center to begin from and a radius to mark. And what this allows you then to do is you can find the intersection from this circle. And that's going to create the other point that forms a parallelogram. So now this set right here, so C to G to this point, we'll label it so we can identify H and then I. So CGHI is another parallelogram, okay, that's sheared from this original ABGC. Okay, and so the way that we can confirm that the areas stay the same on that is if you highlight the vertices. Again, hit Control P to fill the polygon's interior. Now you can measure that area, and you should see that, again, no matter where you move I along this, these two areas will always be the same. So that's the demonstration that shearing will keep an area constant.